everyone, welcome to Mrs. Shin's class. Today we're going to learn about differentiating a ln function. A ln is a natural log. When we have logarithm with the base e, exponential, and then this is equivalent to ln x. Okay, so in the question, if you see y is equal to log base e of x, you can easily change it to y equals ln x. And if you differentiate this ln x, the natural log, it will be 1 over x. Okay, please have a look at this and let's have a look how this formula is applied. Okay, let's see the first question. I have ln in bracket, okay, ln x. This whole thing can be seen as this x value over here. So 1 over whatever the x value that I have. So it's going to be 1 over whatever I have inside the bracket. So if I differentiate the function, it will be 1 over 4x minus 2. And remember the chain rule, you have to differentiate what was in the bracket. So here, if you differentiate the bracket, it's going to be 4, right? So you have to multiply by, like this. However, people, this is not the simplest answer. You can take out 2 to front and cancel out top and the bottom, like this. Cancel, cancel. All I'm left with is this one. Okay, then let's have a look at this one. This is fn function with the natural log ln. Right, what do you think I need to do first? This is ln, so I have to go 1 over. Including that squared, I brought everything down. Okay, according to the chain rule, what do you need to do? I need to differentiate what's in here, but 2 comes down. Minus 1 to the power, leave the bracket as it is. And again, since I have bracket, I need to differentiate this, which is 5, and multiply next to this. Okay, so if I multiply, I'll get that. I have the same thing in the bracket, so I can simplify. And this will be your final answer. Okay, it was too easy so far, so let's make the question a little bit more complicated. I want you to differentiate this equation. What would you do? Okay, so think easy. Yes, I've got really complex thing inside the bracket. I know I've got 2 brackets, right? But I'm going to ignore it and I'm going to see this one, ln everything, as if it's just an x. So I'm going to bring 3 down, x, and 3 minus 1 to the power. Like this. And obviously, what's next? According to the chain rule, I need to, differentiate and multiply. And if I differentiate the ln, it's going to be 1 over, right? And is that the end? No, I have bracket here, okay, that which I haven't found differential equation by. So I need to differentiate this once again. And what is it? That's 3. Okay, now I need to simplify. Okay, here it is. I just multiply top and the bottom, and that's going to be my final answer. Okay, this time, let's make the function gx, and I have fraction. Oh, do you think I can simplify what's in the bracket first? Shall we have a go? Obviously I can break the long big fraction into 2 small ones. And what can you do? Cancel, cancel, and all I left is 3, plus put this on a negative power, so it's going to be x to the power of -1. Okay, now this looks simple enough. I've got ln, so I'm going to differentiate. It's going to be 1 over. And then what do you need to do? I need to differentiate what's in the bracket and multiply. In that case, 3 is 0. Negative 1 comes down, minus a power, like this. Okay, here what I have done is, right, I multiplied it, so that one it goes at the top. Negative 1 over x to the power of negative 2 means x to the power of 2 at the bottom, over, okay, 3 plus 1 over x. Now I'm going to simplify this to this, okay. What I have done is just change that one because it's 3 over 1. So I multiply x top and the bottom so I can add these together. So now x, 3x plus 1. Alright, this one, fraction over fraction. What was the rule? Yep, remember the rule. A over b, big fraction, c over d. Okay, so the closer to the fraction, the number two numbers b, c, are multiplied and goes at the bottom. And the one further one, a and d, are multiplied and goes at the top. So let's apply the rule and have a go at this one. Okay, so this one and that one, which are closer to the main big fraction, I'm going to multiply them, put it at the bottom, like this. And the top one, the further one, negative 1 and x, multiply it and put it at the top. Okay, then I can simplify 1x at the top, 1x at the bottom, and this can be my final answer. Okay, people, so today's lesson, differentiating ln function natural log. If you see ln or log base e, what I'm going to do is think about whatever the value you have, I'm just going to make it 1 over, okay? That's how you differentiate the natural log. Alright, so now I want you to have a go at doing some more questions from the book and make sure you know how to do this. Okay, then otherwise I'll see you in the next lesson. Bye bye.